2001, a single unmanned aircraft crossed the Pacific Ocean entirely on its own. No pilot. No refueling stop. 11,000 miles of open water, and it never wavered once. That aircraft was the RQ-4 Global Hawk. Since then, it has flown over every war zone the United States has entered. It has mapped entire countries in a single pass. It has tracked enemy movements from 65,000 feet, so high that no one on the ground even knows it's there. From the deserts of Afghanistan to the frozen edges of the Arctic, the Global Hawk has become the all-seeing eye of American intelligence. In the missions it has carried out, some of them changed the entire course of a war. The RQ-4 Global Hawk uses a massive integrated sensor suite mounted beneath its fuselage. Its synthetic aperture radar can image the ground through clouds, dust storms, and total darkness. The electro-optical and infrared sensors capture imagery sharp enough to identify individual vehicles from 12 miles above the Earth's surface. In October 2001, the United States invaded Afghanistan. The terrain was brutal. Mountain passes wound through the Hindu Kush. Taliban fighters moved through valleys that satellite passes only covered once every few hours. Commanders needed persistent eyes. They needed something that could stay overhead for an entire day without blinking. The Global Hawk got its first combat deployment. A single aircraft launched from a base in the United Arab Emirates. It climbed to 60,000 feet and crossed into Afghan airspace completely undetected. For over 24 hours straight, it mapped Taliban positions across the Shamali plain north of Kabul. Its synthetic aperture radar cut through dust and cloud cover that had blinded every other asset. The imagery it sent back was so detailed that ground commanders could count individual fighting positions. They could see supply trucks moving at night when the Taliban thought they were invisible. The RQ-4A Block 10 Global Hawk, the first operational variant. 131-foot wingspan, wider than a Boeing 737. Rolls-Royce AE 3007H turbofan engine producing over 7,000 pounds of thrust. Maximum altitude above 60,000 feet. Endurance exceeding 32 hours of continuous flight. Integrated sensor suite combining synthetic aperture radar, electro-optical camera, and infrared imaging system. That single sortie produced more usable intelligence than 3 days of satellite coverage. The data was downlinked in real time to commanders on the ground who were planning the next wave of strikes. No pilot fatigue. No crew rotations. No risk of losing a human life over hostile territory. The Global Hawk had proven something that no other platform could claim. One aircraft. One mission. Total battlefield awareness. But Afghanistan was just the beginning. By 2003, the invasion of Iraq demanded even more from the Global Hawk. Coalition forces needed to understand the entire Iraqi defensive posture before a single boot hit the ground. And they needed it fast. During the opening days of Operation Iraqi Freedom, the Global Hawk flew marathon sorties over western and central Iraq. Each flight lasted more than 30 hours. The aircraft mapped Iraqi air defense networks, mobile missile launchers, and troop concentrations across an area larger than the state of California. In one critical sortie, a Global Hawk identified a cluster of mobile Scud launchers hidden in a wadi near the Syrian border. The coordinates were transmitted in real time to strike aircraft already airborne. The synthetic aperture radar aboard the Global Hawk operates in spotlight mode, focusing its beam on a single target area to produce imagery with resolution measured in inches. This allows operators to distinguish between a fuel truck and a missile launcher from 12 miles of altitude, even through sandstorms that ground all optical systems. Within 40 minutes of detection, the launchers were destroyed. Those Scud launchers had been aimed at coalition staging areas in Kuwait. Had they fired, hundreds of troops could have been killed before the invasion even began. The Global Hawk didn't just find them. It eliminated a threat that no one else even knew existed. Throughout the campaign, Global Hawks flew less than 5% of all reconnaissance sorties, but they produced over 50% of the time-critical targeting data used by strike planners. One aircraft type. Half of all actionable intelligence. Then the mission changed entirely. In August 2005, Hurricane Katrina slammed into the Gulf Coast of the United States. New Orleans flooded. 80% of the city was underwater. Rescue teams had no idea which neighborhoods were submerged and which roads were still passable. Satellite imagery was days old. Helicopter surveys were dangerous in the ongoing storm. The Department of Defense deployed a Global Hawk over the disaster zone. Flying above the weather at 60,000 feet, it mapped the entire flooded region in a single pass. Its synthetic aperture radar pierced through the rain bands and cloud cover that had grounded every other aircraft. The imagery revealed the full extent of the flooding, block by block, street by street. Synthetic aperture radar works by emitting microwave pulses that bounce off surfaces and return to the aircraft. Water reflects radar energy differently than dry land or buildings. This contrast allows the system to map flood boundaries with extreme precision, even when optical cameras see nothing but clouds. That data was transmitted directly to FEMA and the National Guard. The guided rescue boat deployments. It identified which levees had failed. It showed exactly where survivors were likely trapped on rooftops. In a disaster that killed over 1,200 people, the Global Hawk helped save hundreds more by giving rescuers a map they could not get any other way. It was the first time the aircraft had ever been used for a humanitarian mission. It would not be the last. In March 2011, a magnitude 9 earthquake struck off the coast of Japan. The resulting tsunami overwhelmed the Fukushima Daiichi nuclear power plant. Reactors melted down. Radiation began leaking into the atmosphere. No one knew how bad it was. No manned aircraft could safely fly over the site. The United States Air Force deployed a Global Hawk from Guam. It flew directly over the Fukushima complex at high altitude, carrying specialized radiation sensors in addition to its standard imaging suite. For days, it circled the damaged reactors, mapping radiation plumes and thermal hotspots that indicated which reactor buildings were still generating dangerous heat. The RQ-4B Block 30 Global Hawk, the advanced production variant. Enhanced sensor payload bay capable of carrying mission-specific equipment including chemical, biological, and radiological detection packages. Upgraded satellite communication links providing continuous global data relay. Maximum endurance exceeding 34 hours. The radiation data collected by the Global Hawk was shared with the Japanese government and the International Atomic Energy Agency. It showed that the plume was drifting northwest, away from Tokyo but toward rural farming communities that needed immediate evacuation. Without that data, those communities might not have been warned in time. The Global Hawk had entered a nuclear disaster zone where no pilot could go. Then it had done it without a second thought. By 2014, Russia's annexation of Crimea had thrown European security into chaos. NATO needed to understand Russian military movements along the Baltic states, Poland, and the Black Sea. But flying manned reconnaissance aircraft near Russian airspace carried enormous political and safety risks. The Global Hawk became NATO's primary surveillance platform for the European theater. Operating from Sigonella Air Base in Sicily, aircraft from the Alliance Ground Surveillance Program began flying continuous orbits over Eastern Europe. Each sortie covered thousands of square miles of territory along NATO's eastern border. The NATO AGS system uses a variant of the Global Hawk designated RQ-4D Phoenix. Its multi-platform radar technology insertion program, or MPR-TIP, radar provides ground-moving target indication capability. This means the system can detect and track individual vehicles in motion across a vast area, distinguishing military convoys from civilian traffic in real time. During one critical period in 2015, a Global Hawk tracked a Russian military convoy moving toward the Ukrainian border. The convoy included mobile air defense systems and electronic warfare vehicles. That intelligence was shared across NATO in real time, allowing Allied forces to adjust their defensive posture before the convoy reached its staging area. The Russians knew the Global Hawk was watching. That was part of the point. Its presence alone served as a deterrent, a silent reminder that every movement was being recorded. But some missions required looking at places far more dangerous. The South China Sea had become one of the most contested stretches of ocean on Earth. China was building artificial islands on submerged reefs, installing military airstrips, radar installations, and missile batteries on features that had been underwater just years earlier. The United States needed to document the construction and the militarization in granular detail. Starting in 2017, Global Hawks began flying regular surveillance passes over the Spratly Islands and Paracel Islands. From 60,000 feet, they photographed every new building, every runway extension, every radar dome. The imagery was so precise that analysts could track week-by-week construction progress on individual islands. China's island-building campaign in the South China Sea involved dredging sand from the ocean floor and depositing it onto submerged coral reefs. Over several years, 7 features in the Spratly chain were transformed into artificial islands with combined land area exceeding 3,200 acres. The installations include 3,000-meter runways capable of handling military fighter aircraft and long-range bombers. In one pass, a Global Hawk captured imagery of surface-to-air missile launchers being installed on Fiery Cross Reef, a feature that China had previously claimed was built only for civilian purposes. That imagery was shared with Congress and international media. It became the definitive evidence that China was militarizing the South China Sea in direct contradiction to its public statements. The Global Hawk had turned surveillance into diplomacy. In 2020, Australia faced the worst wildfire season in its recorded history. The Black Summer fires burned more than 46 million acres. Smoke plumes rose into the stratosphere. Fire lines stretched across multiple states simultaneously. Ground-based firefighting teams were overwhelmed. They couldn't even see where the fires were headed. NASA deployed its specialized Global Hawk, a modified variant used for atmospheric research, over the Australian fires. The aircraft carried thermal sensors capable of mapping active fire fronts through dense smoke. Flying above the fire at altitudes no other aircraft could reach, it provided continuous overhead imagery of the entire fire complex. The thermal maps showed fire commanders exactly where the fire lines were advancing, which communities were in immediate danger, and where natural fire breaks might halt the spread. The data was updated every few hours as the aircraft circled overhead for more than 24 hours at a time. Thermal infrared sensors detect heat radiation emitted by objects on the ground. Active fire fronts emit intense thermal signatures that stand out clearly against cooler surrounding terrain. By mapping these thermal signatures from high altitude, the Global Hawk can track the movement and intensity of wildfires even when smoke obscures all visible light. In a disaster that killed over 400 people and destroyed nearly 6,000 buildings, the Global Hawk gave firefighters something they desperately needed: the ability to see through the smoke and plan their response before the fire arrived. The Arctic was warming faster than anywhere else on Earth, and as the ice retreated, a new frontier of military competition was opening. Russia was building bases along its northern coast. China was declaring itself a near-Arctic state, and the United States needed to understand what was happening in a region so remote that traditional surveillance was nearly impossible. In 2022, the Air Force began flying Global Hawk missions over the Arctic Circle. The aircraft operated from bases in Alaska, flying north over the Beaufort Sea and into the high Arctic. Its radar mapped ice formations, tracked shipping movements through newly opened waterways, and monitored Russian military construction on islands along the northern sea route. The RQ-4B Block 40 Global Hawk, equipped with the MP-RTIP active electronically scanned array radar. This radar system provides 360-degree coverage with simultaneous air and ground surveillance capability. It can detect, track, and classify targets across an area exceeding 50,000 square nautical miles in a single pass. The Arctic missions pushed the Global Hawk to its operational limits. Temperatures at altitude dropped below -80 degrees. Icing conditions tested the aircraft's de-icing systems. Communication links stretched as the aircraft flew beyond the coverage of standard satellite constellations. But every mission returned with data that no other platform could have collected. The Global Hawk had gone from desert surveillance to polar reconnaissance, from tracking terrorists to monitoring great power competition, from battlefield intelligence to humanitarian rescue. The RQ-4 Global Hawk has flown over every major conflict and crisis of the 21st century. It has mapped war zones, tracked nuclear disasters, guided hurricane rescues, documented illegal island building, and watched the Arctic melt. No pilot has ever sat in its cockpit. No crew has ever risked their lives aboard it. And yet it has changed the outcome of wars, shaped international policy, and saved lives on 4 continents. From 60,000 feet, it sees everything, and it never looks away. If this is your first time here, consider subscribing. We cover the most advanced military technology on the planet and the missions that prove what they can do.